Hello everybody. Today I will be going over 6.3 logarithms and the relation to exponents, as well as some common and natural log, which I'll show you guys later. Now, what is log? Well, log is basically the inverse of an exponential, and I'll show you what I mean by that. So the form for log is log base y equals x. And I'll show you an example of that right now. So in exponential forms, you have your x, which is then by another power, and that will get you your y. In log, it inverses your y, so you get your exponent. So over here, we do log base of 2, 32. Well, it'll give us our exponent that we powered the 2 by to get us 32, which is 5. And that's pretty simple. Let's do some more examples. So if we do log base 8, 64, well, what power of 8 gets us to 64? The answer to that would be 2. Let's do another one. Log 2, 64. Since we did the 32 one earlier, this one shouldn't be too difficult. This one, you guys should get 60. Let's do another one. Log, it's so hard to write with this thing, it's not even funny. 5, 1, 25. And for that one, you will get 3. Pretty simple stuff. Anyway, log is basically inversing the outcome of your exponent to give you what power your base went to get you your answer. So let's compare log and exponential functions. So log, you have your base y, which then will equal your power, or x. Now in exponential form, that would be b x equals your y. And that's how those two are related. So this base right here will be the base for log, and this answer right here will be the number coming right after that. This third number is what you get from the result of the whole function of log. And that's how those two are related. Going back to the original log problems, there are special cases, which I will go over. So in the log world, you can have log, I don't know, I put a G there, log b base b, and the outcome is b. Well, what exponent do you give a number to equal itself? Well, that's pretty simple. That's just a 1. So in this case, when you have a log equation of b, and the next number is b, the exact same number. And so if you're trying to get the exponent, that will always be 1. So if you're doing log 71, and then 71 right here, well, your exponent to get 71 to 71 is just 1. And that's a pretty simple one. For log, any number that you put in after the base has to be above 1, or else it will come out undefined. Negatives cannot be put into log. The outcome of log can be negative, but what you put into log cannot be negative. And I'll show you what I mean by that. So if you have log, my god, that worked out somehow. Anyway, if you have log 2 to the negative 4, and you put that in, let's say, a calculator, it would just come out as undefined. Funny enough. Gosh, I can't write. So yeah, but one thing about log is that you can have fractions. I don't know why I keep doing that. So if you have log base 2 to the 1/16th, let's say, the regular exponent for that would be 4, I believe. 2 times 2 equals 4, times 2 equals 8, times another 2 is 16. Yeah, 4. When you're given a fraction like this after the base, it's usually going to end out with a negative. So in this case, since the regular function would give you 4, it would be a negative 4 in this case. Let's do another one. Log base of 5, 1 over 125. That does not look like 125 at all. And for this one, I'll give you a second. Try and figure this one out. Shouldn't be too difficult. That one you should get negative 3. Because 5 to the power of 3, that's a horrible 3. We'll get you 125. If you want negative, you have to put it under 1, which then will make your answer negative. Okie dokie. Those are some special cases of log. What's next on the agenda? We'll be going over common log. So there are more than one type. I'll just have my editing do that. There are more than one type of logs. We'll be going on to common log. So in common log, every log has a base. In common log, though, the base is set to 10 to work in higher numbers of 10. So if we put in 100, let's say, well, that one's pretty simple. We should get 2. And then if you just put log in a calculator, then the automatic base that it'll give it is 10. If you don't put base for it, starting off. So if you just do log 8 in a calculator, this base, even though you can't see it, it will always be 10, unless you put it in yourself. And that's what common log is, basically, just having a fixed base of 10. And it works really well for big numbers too. The next type of log is natural log, and this log is with the constant e. So this log e, and e is equal to, text box right here, 2.71828, if I remember correctly. It's a base, by the way. And that's Euler's number, which is constant used in engineering as well as calculus. And log base of e is also equal to I n x, which is a whole other function there. So let's do some review while we're here. So log 2 60 64. That's a horrible 64. So in log, you have your base and your outcome. You are getting the exponent that your base was powered on to get your outcome. So in this case, the answer is 6. And if you do 2 to the power of 6, you will get 64. Look at that. So then this number is your outcome. This number is your base. There. This number is your power. So in log, you're literally inversing your exponential function. Funny how that works. And then next topic, review over converting, which is pretty simple. That's also here. That's the base, which you can put right there. Your outcome, which is your power. So if we had log, let's say 49 and 7, you can get fractions as an outcome. I don't know if I didn't say that before. And for this, you should get 1/2 because 7 squared equals 49. But 49 is our base, and 7 is our result. So our 49 is to go to the power of 1/2 to get 7, because 1/2 in the exponential world is also square rooting. Accidentally opened Siri there. Cancel. Okay, clear that. And then common log has a fixed rate of 10. Fixed base of 10, my bad. So log, that's the most basic form of log. That's why it's called common log, I'm guessing. Log 10. That's common log. Log e, that's natural log. And I'll end it off by giving some examples of each. So we can do log 64 8. See what that'll give you. Log 10 10,000. I'm really hoping this video isn't more than 15 minutes long. Log. We'll do a conversion on this one. What would be a good number? We'll do another 10, why not? 10, 100 equals 2. Turn that into an exponential function. Let's give another example of each. Log. What would be good? 5, 675, is it? I have to check on that. Oh, it is 25. See what you get out of that one. And I think that's what I'll leave it at. Alright, sounds good.